I am Allison Goodman. I'm a senior principal engineer for our Optane solutions, and I'm happily joined today by Biswapati Bhattacharjee, who is a senior product line manager at VMware. So hopefully he'll get to do a lot of talking about our VMware and Intel collaboration in this space. I'm going to just reuse this picture and this framing that we started the Storage Tech Field Day with today, which is this evolving memory and storage tiering, really where we have this gap that we're looking at Optane as filling some of that performance and capacity space. And I'm sharing it partially because Intel and VMware have really been collaborating on the storage tier for quite some time now. VMware has a system and a software architecture that really fundamentally understands and uses tiering. And especially for vSAN, where we started a while ago, our initial Optane engagement, that vSAN data path, it efficiently utilizes the storage tiers. And so when you look at just adding additional faster tiers and using that same basic data pattern, it works really well. And so we're collaborating together, using and incorporating Optane as a cache tier. And Biswa will talk in a few minutes about the focus of their vSAN solution and then how Optane fits, bringing high performance for both hybrid storage and all flash storage deployments. And we didn't stop there. Luckily, that was a very initial collaboration. And we've added persistent memory support in the memory tier as to offer a cost advantage as you get denser VMs and workloads that really demand a larger memory footprint. And so you can get the same great performance and less cost by just doing that denser workload and using that memory footprint. And then as the vSAN architecture is continuing to evolve and be more performant with NVMe, we're continuing a collaboration on those data paths to really optimize the best performance at the optimal capacity and cost points. And that really means utilizing Optane persistent memory and SSDs, TLC and QLC in ways that are most efficient and effective for those media types. It's kind of getting the best out of the media types. And a lot of that, getting the best out of Optane, as you've heard from a lot of our other examples today, are considering small metadata writes on Optane, and then getting to those larger sequential writes for endurance on the QLC media. And that really allows you to optimize for the most predictable and consistent reads across the media types. So I'm excited about our deep and ongoing partnership between Intel and VMware. We learn a lot from each other and are able to stay on the cutting edge of memory and storage tiering. And with that, I will turn it over to Biswa to just give us some overview from his side.
So thanks, Allison. Thanks for inviting me in the presentation. So hi, everyone. My name is Bishwa, and short. My long name is really long. So I work in the VMware product management team, and I primarily focus on our ecosystem partners in terms of enabling the various technologies which we closely collaborate on that. Intel is one of our very close partners where we have been collaborating in various technologies over a period of time, and we continue to do so. I will let Allison towards the end to cover a little bit more on the memory tiering and whatnot, which is the primary focus of today's discussion. However, just to give a quick overview on the vSAN side of thing, I thought I'll put like 1 or 2 minutes on what vSAN is all about, and then gives a kind of a high-level view on how new generation hardware been adopted in the vSAN side of things. So to start with, I'm pretty sure most of you are aware of the product is there in the market for quite some time, and it's essentially a software-defined which can run on a standard x86 hardware. Fundamentally, it brings in the server-attached local storage and creates a shared pool where the VMs can run today. And it starts with the 3-node. There are 2-node robo deployment with witness can be on a separate one, and however, it can grow up to 64 nodes in a single cluster. So, and in each of the nodes, we call it a concept called disk group, which is a vSAN construct where one of the devices is going to be cache, and it can have 1 all the way up to 7 maximum number of devices can be treated as a capacity. and it's a well integrated within the VMware stack. There is no separate sort of vSAN installation or configuration needed. It's part of the vSphere itself, where you could get an opportunity to do all the policy management and whatnot from a VM level rather than going into the storage side of things. So that's at a pretty high level, in a very basic way, how vSAN is look like. So server-rated local storage has been created as a pool of resources to provide the shared storage across all the VM running in the vSAN cluster. Cool. So I think today, vSAN started the journey with a traditional workload a long back, and I'm sure Allison is going to touch upon some of the use cases at a broader level. But today, vSAN supports all the different protocols or the accessibility, whatever we call it, from a vSAN standpoint. So you can have a traditional workload, be it file services or for the matter of the cloud-native applications, it all can run in a single platform. It's the same way. I mean, you could run both the business critical apps and all the cloud-native apps in the same platform today when you're running vSAN with the vSphere in it. So it's not a separate kind of a different clusters or siloed kind of an approach where all workload can potentially be run depending on what kind of a demand they have within the single vSAN cluster being part of it. So it's kind of a journey which have been there from starting from the traditional workload all the way up to cloud native today, been supported by the vSAN from a workload standpoint. And finally, and maybe Allison, I'll take another 15-20 seconds in the next slide to show how the next generation is being. So now, as I mentioned, when vSAN started the journey, it was primarily based on, it's a two-tier architecture today as well, where we saw that initial days, it was primarily the SaaS devices, SATA devices being considered in the cache, but as kind of the deployment grew and many, the data centers and all these things have been adopting to the next generation hardware devices like Intel Optane and high-end NVMe devices, we do see that many of our new workloads require those NVMEs and whatnot in the cache, as well as in the NVMe in the capacity tier as well, which are not as high as Optane technology, Optane related devices, but more of a low end or a performant kind of an NVMe devices. So from a journey perspective, both previous generation of devices and whatnot in the data center, as well as the new technology, as Allison highlighted, technology like Intel Optane, are all being supported today in the vSAN. And we do see there are a lot of all NVMe ready nodes and whatnot being created across the OEM partner ecosystem. And when you talk about the OEM partner ecosystem, we have about 15 plus OEM partners today who are basically part of this program, where they've been supporting various vSAN configuration as part of the ready node, like a small, medium, large kind of a thing, where Optane is kind of ubiquitous across that ecosystem partner when they support it.
In the caching tier, you show Optane there. Is that PMEM or is that SSDs or is that both? Or
this is SSD. So PMEM in memory mode is also supported today, and I'll let Allison to go a little bit on it. But this Optane is about the Intel SSD Optane devices.
I gotcha. All right, thanks.
So that's kind of a transformation we do see where customers are adopting towards this latest and greatest from a next generation hardware perspective as well when they're running vSAN as part of their refresh or greenfield deployment and whatnot. So that's kind of a very short and quick overview in terms of where we are from a vSAN standpoint on the platform side on the Intel technologies. If you have any question now or later, I can stay back and address. But Allison, I guess with that, I would pass on the baton to you to cover on the memory tiering structure of the side of things.
Sounds good. I'll add one comment on this slide because I think that one of the powerful uses of Optane that I've seen as we worked with a lot of those customers that Biswa called out to really deploy vSAN is that there's the power of being able to do both reads and writes really well with high endurance makes it a great choice when you have just a slower capacity tier where you really need some amount of read buffering while those writes are coming in to sort of get the performance that the system needs, as well as when you have a very fast, kind of alluding to the right picture, like a very fast NVMe capacity tier where your reads are fine, but you can really still get a lot of value both from an overall performance. So it's just you can fit even more VMs at a high performance point, as well as low latencies of having Optane as that initial caching tier that's essentially holding all that write buffering before it goes out to capacity.
Maybe I missed something here, but can I use QLC as a capacity tier? And if so, what kind of optimization do you have in the stack to make sure that I'm not, wearing out the drives quickly?
So let me take the question. So today, in the current state of the vSAN, we do not support QLC devices. However, like Allison mentioned, right, we have been collaborating with our partners and we are exploring into that area as well. That's the short answer. And I think we have pointed out, right, QLC has its own variant tier. So we would be working, and this is futuristic. I don't know, I can comment on details about it, but we certainly are exploring on that area together with our partners.
Okay, thank you.
Yeah, I'll add as a blanket QLC comment as that QLC technology matures and we really look at like how to get the most out of QLC. The better performance does come from having more sequential writes. So you really want to get to sort of a minimum write size. So that's going to just overall reduce the amount of write amplification and background, which then in turn allows you to kind of keep up with the reads as well as the write performance, because you're typically doing both on a drive at the same time. And so, as we collaborate with VMware, that's some of the things that we're looking to optimize and being able to get VMware to support QLC is like how do we get in the data path, the right changes so that you can really treat QLC the way that it needs to in order to get the performance that you want out of it, and be able to kind of take advantage of that lower price point and larger capacity.
Just going to jump in quickly with another question. Are you seeing anyone mixing the Optane front end at the cache level with spinning drives at the back end? Or is anyone who's making that jump to Optane going full flash across the board?
So we do see primarily an all flash. When Optane is in the Intel Optane SSDs in the caching tier, it's primarily an all flash. And the capacity tier could be an NVMe, which for the lack of time, I will say mainstream NVMe, which are regular SAS SATA kind of NVMe devices, or it could potentially be a SAS or SATA as well. I don't think it's as prevalent when someone is utilizing Intel Optane SSD in the cache and HDD or the spinning media in the capacity tier, because the workload which may require Optane as a cache potentially will also look for a high-end capacity devices today. And I believe, again, these are more details. I'm not sure how much details I have or could provide here, but essentially the prices of those NVMe devices or the adoption of those devices falls in the same bucket as all with the other SAS and SATA SSDs in the market. That way it makes more sense from a future-proofing perspective as well as getting the entire benefit out of the new generation of NVMe devices.
Okay, no, I was just curious if you've seen anything in that space, because it seems to me that's the cost trade-off, no matter what you do, is whatever you do, a spinning disk will also always be lots cheaper. So if you can throw front end with the best performing Optane, and you take advantage of the fact that you're doing read caching on the vSAN hybrid configuration, if you're getting 90% cache hits, you're doing pretty well. Obviously, you're going to see high latency variability if you have to drop down to the disks. But in a lot of cases, you could be feeding your workloads quite nicely.
Yep. I think in general, the trend is about all flash when Optane is in the cache, but potentially it could be a approach where certain workload may require that. I see your point.
Just an idea.
We certainly see, Eric, a balance of that data flow, especially on the right side. So you can imagine, because the cache is sized obviously at a smaller percentage than that overall capacity, in order to really balance the system out, you need enough throughput on that capacity tier to keep the data moving off the cache. And so that's why I think we typically see more of like SATA or SAS NAND drives than the spinning rest drives, just because it's harder to get that balance, to get enough spinning drives to sort of keep the data flow and not stall it out, depending on how many writes you're demanding in your system.
Okay, thanks very much.
Quick question there. Wouldn't doing something with NVMe namespaces kind of alleviate that if you could use the same devices for both cache and capacity and have the exact same kind of performance on it?
Yeah, I think some of our partners have done some experiments, and those things have been in the public domain. But today, in the current vSAN, we are still not supporting, at least on the on-prem side of thing, from a NVMe multi-namespace, if I call it, right, where a certain device can be carved out logically and each volume can be treated as a device. This is, again, an exploratory topic. I'm not sure how much I could go into detail, but we do have some of our partners did some experiment, because in the core vSphere itself today, the multi-namespace capability been enabled in the recent releases. I don't have top of my head the release or whatnot. So where they did some experiment where they deployed, or they took the vSAN, took that NVMe device and make it like a multi-namespace where they carved out cache and capacity and did some performance exercise. But officially, we're still not supporting NVMe multi-namespace. This is something we're certainly looking at. Maybe some of the use cases would be valuable where you may have, less number of drive slots, could be an edge use case or something of that nature. And certainly we are looking into that, but not today. We are supporting the namespace from a vSAN standpoint.
All right, so it's interesting for a two-node robo-cluster kind of use case, right? Where you can have a smaller number of devices in a smaller case and a smaller physical footprint
Right.
and provide the same kind of performance. So, but
I know. Sorry, go ahead. Please finish your thought.
I believe you're actually doing this in VMC on AWS already.
Yes.
So
yes, that's what I'm saying on the on-prem side of thing, and I think you have all the details. So we have ecosystem partners, server hardware partners, who has platform which are capable to do that, and they are planning for having more and more to scatter to the need of specific use cases, and we are certainly looking into those areas and see what all things need to be done in order to extend support for those deployment and whatnot. So that's where we are today.
All right. We talk. I guess now a little bit about persistent memory in addition to those Optane SSD cases. So this is another area where we partner with VMware to offer a cost reduction with comparable performance. And so starting with the vSphere 6.7 EP10 release and later, customers can actually incorporate Optane persistent memory to increase their memory capacity and improve the TCO for relevant workloads. So if you take a look at the picture kind of on the far left, this is an overview of memory mode. So when we talk about memory mode, this is really a hardware-supported transparent tiering. So the DRAM is cached into the persistent memory. And so there's a set of workloads, and this is really an emerging set of workloads where we see more and more that need larger memory footprints. And so it's a great use case because the DRAM cost can really come down when you start augmenting, take a 2-socket host that has 512 bytes of DRAM in it, add a terabyte or even 2 terabytes of persistent memory. And so then you're able to have and show quite a large memory footprint at a lower cost than you would if you were trying to present it all with DRAM. And so then that additional memory is then available for additional VMs. And what we've seen is that we're able to maintain that consistent performance and latencies with the active piece of that footprint.
Hey, Allison, what's the ratio of PMEM to DRAM or DRAM to PMEM in these sorts of memory mode configurations?
So there are some different ratios, and at this point there's a set number of configurations and supported ratios that we have with VMware, and so that's sort of the deployed set of ratios today, and we're just working on continuing to expand that. So we're getting some additional device monitoring into the performance monitoring system so that we can expand the number of ratios.
And you would pick a particular ratio based on some workload, let's say if it's VDI or high compute or something like that. Yeah,
that's right. Yeah. because you want to do a characterization a little bit to make sure you understand what your active memory footprint is versus sort of the full amount of memory that you need for that VM.
I got you.
Because the more that you can get the active footprint in DRAM and then sort of do your spillover into PMEM, you're going to get the best performance characteristics.
Gotcha. All right, thanks.
Yeah. And then maybe to touch on my last comment on my table there around boosting the I/O performance. The other thing that we see in these memory mode deployments is that with that larger memory, you're just you have less disk I/O. You're going out to disk fewer times, and so that's just going to overall improve the system performance. So memory mode, which is very much a memory tiering construct. In addition to that, we've also partnered with VMware to offer this app direct mode. And so the bottom picture is kind of representation of this app direct mode where you're actually aggregating the capacity. So in this one, you have DRAM and PMEM kind of as a combined capacity. So if I go back to if you have 512 bytes of DRAM and a terabyte of persistent memory, in this case, your system would show 1.5 terabytes of memory. And the support for App Direct then gives some greater flexibility for applications to take advantage of both types of memory being available. The applications actually see the persistent memory, and then they can make choices to actively place data in DRAM or PMEM. And so as our list of enabled and optimized persistent memory applications grows, they'll be able to run and deploy very efficiently in vSphere with that support. And then maybe I'll just add a plug to your question, Ray, which is one of the great value adds with the persistent memory usage in vSphere is this ability to use the memory active and the memory usage indicators to monitor how much DRAM and persistent memory is being used. And so it just kind of helps make sure that you have the right fit for the ratios in the system that you're deploying.
Allison, with the dual modes of Optane is one of the challenges that I have with the product.
Yeah.
I'm keen to have people use more of the app direct mode, but I appreciate that there's issues with getting programmers to be able to use it well.
Yes.
So with the capabilities that you're providing into vSphere, are they then passed through into the virtual machines themselves to be picked up by programmers in those environments? Or is this something that is going to be used by VMware themselves running the vSphere hypervisor environment, and it's going to be transparent to the VMs that run in that environment?
So today's state, the App Direct support is transparent to the applications to use right now. So I'm going to use an example like SAP HANA. So SAP HANA, which is already optimized to use persistent memory in App Direct mode, you can run SAP HANA as a virtually in vSphere and be able to then use persistent memory support that way. So the second part of your question, which is as vSphere starts to use it, maybe in a way that's less transparent to the applications and more so for vSphere, that's all work and discussions ongoing.
Cool, thank you.
Yeah. So we went through with Biswa's help some of the ongoing SSD collaborations with the current, and then kind of looking forward to the next generation of vSAN, and then the ongoing persistent memory support. The few of the ways that VMware is really leading with Intel and using Optane to fill these memory and storage performance and capacity gaps. I'm looking forward to continuing our partnership with this cutting edge technology and kind of finding creative ways to continue to get good performance with lower TCOs.